Yeah, welcome. Great to see you all. Thanks to Bouvet hosting us. This is a joint meetup for the first time between the domain-driven design meetup, represented here by Trond, and me, Fede, from Oslo Software Architecture. So we did a crazy experiment. We split the registration half here and half here. So yeah, we won't repeat that. But you made it. That's very nice to see. So if you're not a member of one of these groups, yeah, then just sign up. There's a lot of good stuff going on. Yeah. You want to say something about the DDD meetup?
Alexei ran off to pick up the main guest here, so he asked me to say a few words. Give it a try at least. And my name's Sean, I'm going to speak later on, but I just want to start off saying I'm really amazed that so many came to a DDD meetup. It's basically a DDD meetup, regardless of Oslo software application. So, I mean, Vaughn is here, so that's the main character, I suppose. But I just remember a couple of years ago, after domain-driven design Europe, there were a couple of guys who tried to start a meetup on domain-driven design. There were just a handful. It didn't get going. Then Alexei started last year, and he started a proper meetup, and then it really started. So this is amazing. This is way more than that. Thank you all for coming, and hope you enjoy it. And then I leave the words to Thomas there from Norway.
Yeah. So if you didn't get the last update, we will have a short lightning talk from Thomas here. And then Vaughn will be, he's now been driven up here from his course, implementing domain-driven design, his workshop. And after that, we will get Trond to speak. So that's the agenda, right? Did you start recording?
Okay. Hopefully the sound will be nice and stable. Yeah. Good. I'm really happy to see so many people here. I've been asked to hold just a short lightning talk, so we have a pause number before Vernon shows up. And I'll talk a bit, short talk about how we use domain-driven design at an enterprise scale. I've been working with enterprise architecture last 7-8 years or something. And also been involved in a lot of projects that's been defined from the enterprise architecture effort. And I found a lot of the methods and stuff really useful also on that scale. So you can communicate, the whole architecture, the whole portfolio, all business units, that they actually can communicate better together, so that the portfolio and enterprise scale improves over time. Okay. Okay, this talk summarizes the work I've been doing at the Norwegian Tax Administration for some years. I work now at Bouvet. I'm back here again. And right now I'm also working with information architecture at .NET, where we're using the same domain-driven design for getting an overall information architecture in place. Okay, so what are the tasks at the enterprise scale? Because we know there's a lot of business units, they all have their own language, and they communicate partially through with each other. And a lot of the challenge when you come into the digital world and want to challenge, the challenge is digital transformation, where you want to redo your business with IT support, not just working as you did in a manual world, and where every business unit pretty much did the investments by their own. So how do you facilitate that change from where you are today into some future where you work with a lot better IT support, with improved business processes and reuse of information? And a lot of effort has been going into defining a target architecture, a place you want to be. But I think a lot of enterprise architecture effort has failed because they haven't been able to talk about what the change is, so that the people in the organization can talk about the change and talk about the new stuff you want to do. And the new components, the new business capabilities, new services, maybe a better name on a set of information which is not visible if you can't talk about it. So it's a lot about building a vocabulary for change, and that's where the almost impossible English word, the unique language, ambiguous language comes in. Okay, so in that work, there's a lot of work in finding the bounded context. And when you look to the language people speak, they are often bounded by, the silo systems maybe, or the business units. But often you understand that you crossed a bounded context when you try to understand what people are talking about, when you find a specific term or something that they're discussing. So identifying the bounded context and also digging into the language, an iterative process, going through all the business units, going through all the silo systems and understanding what's going on in the different areas of the company. That's a good start. But then you need a primary or a high-level planning tool to find out where are you going. So when you look into and find what's beneath all the information flow or the system services, you see that there's a different composition of where you want to go. That's a better target. And it has to communicate to everybody. And it will be a guide and constraint for future projects. So to define this is a planning tool so that you can plan the projects that mostly of you are working in. And you can steer the project portfolio over time in many ways that you actually steer how you build a city. So in the drawing I will have on the next page, you'll see that the business capabilities and the bounded contexts are drawn as a city map. And then you can talk to all levels of the organization, the steering committee, the owners, etc. And you can talk about how the system portfolio and the business services will evolve over time in many ways as you plan a city, and talk about how the city will evolve. At this level, we don't really care about how each and every project is solved individually, if it's Java.net or if it's something you buy. But we want to make sure that things are built according to plan over a long period of time. And we also want to have an agile approach to everything you learn as projects go by. Okay. So this is the city plan as drawn at the Norwegian Tax Administration. It was finished, I think, last autumn. As you see, it's it looks like a city, and it's quite blurred because I'm using the image that they are using on their blog, so I can't use the high-res image since I'm not working there anymore. But still, you can see the overall idea. Out here, you have the customers coming in, and for you who are familiar with Norwegian systems, there's Altinn here, for instance. And here you have the buildings and the bounded context of the services offered externally. And as you enter into the city, you'll see a large square here. So here's where the core of the future state of the systems will look like. So you have an area here which is assessment. That's where you calculate tax, for instance. In the middle, you have search, security, and pretty much case handling, process handling. At this level, you have all the parties and documents, and you have the collection systems over here. And at the back, you have data warehouse and analytics type of systems. So the business, when you talk to the business or anyone in the organization, you can talk about how things happen out here. You can, pretty much walk or tell a story as you go through the city. Things are calculated here, information flow in between here. Security is always handled here. And so you can visualize new capabilities, new processes through all the business functions we have, the services, etc. we build within the bounded context. So you see these areas are in the bounded context, and the services are pretty much these buildings, which also we can translate to business capabilities. And to go back to the colors, they also show the maturity of the different parts of your architecture. The blue is something that is ongoing building or construction. The green is where things are okay. Red are things for large systems to be deprecated. And yellow are something that's planned but not being constructed or financed yet. So when, let's say one of you come into this organization and you want to work on a project, then I could tell you that, yes, you're going to work here, that's your slot. This could be a large project, 50 people, some years or something. But still, this is a map where you can talk, oh, this is one part, this is another part. These are different aspects of things you have to communicate, know about. Because if there's something that always happens if you get into an organization, you read your project mandate, and then there's always someone drawing on the board, trying to illustrate all the systems you have to integrate to, and things like that. Now this map can be used for maneuvering also in the organization when you want to find out where to integrate and stuff. And it's also used on the board. The Ministry of Finance in Norway has seen this picture and she liked it a lot. So it also communicates on a political level. And that's great because we loved it, because everything that's new is blue and everything that's deprecated is red. So we scored a really cheap, some cheap points there, but and the green is really stable, nobody bothers. So well, anyway. But still, you can tell a story on all levels of the organization of how you want things to be. And so that's a way to illustrate your domains, a way to let the language of the different areas shine through and show your more or less modules or services as business capabilities. And have a tool so you can talk about change and you have a language for change. Because people have to change, organizations have to change, business processes has to change if you want to have a transformation in the organization. And the other part of it, if you don't accept that, you will just rebuild systems as they were, and nobody has change. Okay, that's a short talk on using domain-driven design on enterprise level. I've been holding some talks. They are on SlideShare, so some of my work is here. And actually, this drawing brought us to Global Architecture Excellence Award in India, in Bangalore, 2.5 years ago. So that was a lot of fun bringing my boss down there and having vegetarian food on the other side of this planet. Okay. Thank you very much. Okay.
Yeah, so welcome, Vaughn. Finally, we see you again. So Vaughn is here directly now from his class, as I said, implementing domain-driven design workshop. And you may be wondering why we just didn't stop at Trond, since Vaughn was a bit late. But Vaughn said, I don't want to miss a minute of Trond's talk. So yeah, it puts a lot of pressure on Trond. It's a new talk.
No pressure at all.
Yeah. We're very happy that after a long day of teaching, you are here. So we're super excited. Please take it away.
Okay.
Yeah, that's good too much.
Oh.
One for the recording.
Ah,
Okay, and why
to Alexa for driving me here, and I did arrive just about as soon as possible. So, yeah, so I'm talking this evening about reactive DDD. Is that a new DDD? And you know, what kind of situations do we get into when we are developing reactive systems? And it introduces uncertainty. And how many here are using distributed systems, or you are developing and deploying distributed systems? Wow, everybody. Not maybe everybody, but many. So I think you'll find this interesting. Do you experience uncertainty in your distributed systems? Like, yeah, what failed, right? How does it go? A machine that you didn't know existed causes your service to fail. So, you know, how do we deal with the uncertainty and you know, microservices are definitely a thing. I have an opinion about what I think is a good place to start with microservices. I think it's you know, probably a DDD boundary, what we refer to as a bounded context. I'm not saying that that's the only way, but here's an alternative. You could develop microservices that are the size of a single entity type, and maybe you'll have thousands of microservices then, maybe tens of thousands. So, you know, I'll let you do the research yourself, but there's a person who takes credit for inventing or, you know, creating the idea of microservices. This individual used to be a ThoughtWorks employee and I think quite well known. And so I've, you know, and you can watch this very video on YouTube. And this individual says that the right size for a microservice is about 100 lines of code. I'm not sure how that works out, and I'm really being honest. I'm not being only sarcastic. I am being sarcastic, but not only sarcastic. But you know, think about that: 100 lines of code, and could you have 10,000 or more microservices in a single whole system solution that way? I think it's quite possible. There are so many microservices in this kind of solution that this individual, you know, credited with coining the phrase or the name microservice, says that they can't keep track of which services are still relevant. So many microservices that we're afraid that if we unplug one, it might break everything or a few things or a lot of things or something. So we just leave them all running. And their justification for that is it only costs roughly $400 a month to leave a microservice running. And so why worry about whether or not it's relevant? And then if you keep on this path, you know, you can imagine, I mean, it's probably been 3 or 4 years since that video was captured. You think maybe there are 40,000 microservices now? Do you know what I hear from that? And it took me a while to kind of wrap my mind around what really bothered me about that. It's the same problem that we have with a big ball of mud, just a little different. So it's a distributed big ball of mud that we're afraid to touch anything in the distribution of the system, because if we do, we'll break something. What does that solve? I'm not sure I understand. So And talk about uncertainty, right? This is uncertainty at a classic level, where you literally do not know what the system is doing anymore at any given point, except for maybe what you deployed in the past few days. So I'm talking about uncertainty this evening, but I want you to understand I'm not talking about uncertainty at the point where you cannot reason about the uncertainty that you face with distributed systems. Okay? I think that it's important for teams to be able to reason about their systems and model and get good results from them. So that's my kind of context that I'm setting. All right, so the essence of domain-driven design has not changed since Eric Evans wrote his book in what was it, published in 2003, I think. And so the bounded context and the ubiquitous language are still the hallmark of DDD. It's the thing that we really focus on modeling a language as software inside a boundary, and that boundary gives a context that enables the team to reason about the meanings of everything inside that boundary. So we have a clear meaning of the language inside, the language we speak, the language we write, documentation or whatever it happens to be, the language of the diagrams that we draw, and the language of the model that we implement with some programming language. Okay. So that hasn't changed. And another thing that hasn't changed with DDD is the context mapping. So because we work with bounded context, and we say that if, we reason that if something, some concept maybe has a similar name or the same name as a concept in another part of the business, and that concept, though having the same name, has a different meaning, then we divide those linguistically. We're saying that per the language definitions, those belong separately, because we're purposely avoiding a canonical model where we're trying to model the entire business domain, everything in the business or everything that's important to the business in a single canonical model. Because, just take any concept, if you will, the concept of product. Okay, the concept of product, just take an e-commerce setting. How many different definitions is there of a product across the, everywhere from putting a product into your shopping cart to that product goes out the big door of a warehouse in the back of a truck. Okay, that definition of product probably changes at least half a dozen times, 6 times, maybe more than that, probably more, depending on the complexity of the environment. So context mapping helps us to solve the situation where we have different meanings of language, and therefore we have of necessity in domain-driven design multiple bounded contexts. And context mapping says, that this line that we see here has a specific meaning in that it represents a team relationship, or teams, and how the teams relate between this bounded context and this bounded context. What kind of relationship do we have with them? And what are not only the terms of the integration with them in terms of, are we a customer and they're a supplier, or do we consider that relationship a partnership because we're in close alliance with our business goals and we're helping each other to deliver? Or are we conformists to their model because there are certain aspects of their model that are too complex for us to translate into our own language, and so we're going to adopt part of their language and, as part of our language as well. And so we have those kinds of relationships and collaboration and integration, both at a team level and at an informational level or a linguistic level as well. But then we also have the technical integration itself. Are we using, so we've kind of, looked at two levels, and now there's the third level of, are we using SOAP, XML over RPC? Are we using REST? Are we using messaging? What, do we have a proprietary binary protocol over some, network? So we have to think about all these aspects, and context mapping helps us to understand the situations that we're in, both in our relationship with other teams and how we're going to work. And it's great to understand that, because if we don't have a good understanding of it, you can imagine what a failures candidate your team is to think that you're in a partnership with another team and you're really a conformist to them, or a customer to a supplier, and you were expecting them to be more helpful, and now they're really not, and they aren't delivering, and you have to say please instead of we need this by a certain date. And so knowing those things is quite important. So DDD from that aspect hasn't changed. What has changed a little bit since Eric wrote his book is that he introduced more formally the idea of a domain event. Now, if you read his blue book, you'll see evidence of events existing in his mind and already in solutions at that time, but he hadn't called out and actually written a pattern or a codification of the domain event in his book. But so there have been a few little changes, but primarily DDD is quite a bit the same. And now, we introduce distributed systems into the mix, which I think, that there were sort of distributed systems in the early 2000s and before. Of course, we were using Corba well before that, and DCOM, and what else, RMI, and who knows, right? Maybe a non-standard protocol between systems or subsystems. And so, when we look at an image like this, what does it represent? Is it, okay, is it the Milky Way galaxy? Or does it represent the nodes on the internet worldwide? Or is it the individual objects in a complex system? Well, if we jump at power, have you seen the IMAX film? That's sort of like the powers of 10, and you zoom from the minute, what's inside an atom, all the way up to stars being born. It's pretty incredible, right? So, but, we see these kinds of patterns everywhere, but when you have this kind of complexity of all these things going on, whether or not we're talking about a single entity type as a microservice here, and we have so many of those that we can't reason about, what still is relevant, what should be running and what shouldn't be running anymore, or if these are how many actors we have in an actor-based system in a single bounded context, potentially millions of them. And they're all talking asynchronously, sending messages around, and how do we deal with that? Is there a practical way to reason about the uncertainty that occurs at various powers of 10? Now, why do we use, for example, actors today? Okay, Well, it's because we don't have faster processors. Roughly speaking, Moore's law applied up to about the year 2003, and Moore's law said that about every year and a half to 2 years, we were going to see double processor speed increases. Every year and a half to 2 years is what it proved to be. And then about 2003, there was this almost screeching halt to that. And now to get the same kind of double in processor power that we saw, that we were benefited by over time. And I'm old enough, I've been doing this for 35 years, so I can remember when getting those new machines was just like, yes, yeah, every single time. But we come to this screeching halt in 2003, and now it takes about 9 to 10 years to see that kind of performance boost in a processor. Okay? And there are various reasons for that. But what we are getting is more cores. I mean, on this simple little Mac, right, that's I think 3 years old now, it's 8 cores. And I mean, you can easily buy servers with 24 cores. If you really try hard, you can find servers with 80-some cores and maybe even an Intel machine that's really beefy with 200 and some cores. So that's how we're answering the kind of power boost questions that we used to get. We get more cores instead of faster cores. Okay, so yeah, that's cool, right? He has to tell people who he is. But Donald Knuth is misquoted a lot. Have you heard this quote before? Premature optimization is the root of all evil. Yeah. Do you know he said that? But it's context with DDD is so important. It's context is important too with quoting people. Donald Knuth said this, actually. We should forget about small inefficiencies. Premature optimization is the root of all evil. Wow. That's quite a bit different than premature optimization is the root of all evil, period, right? The statement, forget about small inefficiencies, is a very important qualifier. And having software that uses a single core on a multi-core machine is not a small inefficiency. That is a tremendously wasteful inefficiency. So the software that we write today should be very concerned about the big inefficiencies of not using all the cores, that we have available to us. Okay? And here's another thing that Donald Knuth said, which I think you'll find interesting in this particular context. He said that people who are more than casually interested in computers, like us, right? I think most of us are probably more, you're taking a Thursday evening when you could be home with your family or drinking a beer, well, you got beer, okay, maybe that's why you're here. So I think we're more than casually interested in computers, should have at least some idea of what the underlying hardware is like, otherwise the programs they will write will be pretty weird. So have you seen this video? You know what, I want to see if can I project my browser? Sometimes this works, sometimes it doesn't. I can, good. I want to show this video, it's really cool. It's, so it's breakdancing. I showed this earlier today. Breakdance. Oh, that's right, I don't have the internet. Can I get someone's, what is it? Oh yeah, I had my Wi-Fi turned off. Okay. There's one problem. This one?
I guess.
Yes? Oh.
2012 eller 2011.
Oh boy. That's going to be impossible for me.
Try 2012.
What is it?
2012 or 11.
2012? I'm sorry, what? B-O-V.
Same as the name of the guest.
Yeah, but I'm not looking at that. So B-O-U-V-E-T. Is it in mixed case? B-O-V. V-O-U. V-E-T. 1, 2, 3? No. 2012? Oh, okay. Got it. Okay. Now, everybody ready for this? You got to pay attention. This is a breakdancer representing a multi-core processor. Right? Now look at this breakdancer. You know what that is? That's CPU 0. What are all the other CPUs doing? Right? Go, baby, go. Yeah. Come on. Yeah. Yeah. Up. Oh, no. Oh, okay. Yeah, so I think you get the idea. Now, would you agree with Donald Knuth? That's pretty weird. How much software is running out there today that is using the computer in that very way? I think a lot. There are a lot of weird programs out there. Okay. So, yeah, since 1973 until 2003, look at what processor speed was doing, and then, right? Why did I choose the year 1973? Because that's when the actor model was introduced by Carl Hewitt. Carl Hewitt envisioned this point in time where we would have multi-processors. I don't know that he actually saw cores being part of that, maybe he did. Fast networks, vast networks. And Carl Hewitt said, notice I use circles instead of rectangles. This means actor. This is different than it is an object, but it's a better object than objects. And so Carl Hewitt said, there's going to be a point in time where every little object in the system will be its own little computer. And you know who agreed with him on that? Alan Kay. Alan Kay thinks that the actor model is really, the closest to what he envisioned object-oriented being. So, yeah, reactive with actors. This is where, in a system, okay, we have reactive because we have maybe different kinds of messages, event messages, or maybe some command messages going around microservices that are also DDD-bounded contexts. And those microservices themselves, or bounded contexts, are reactive because they are reacting to incoming stimulus that they're interested in terms of events. But we're also talking about reactive inside here. Right? So the little objects, the little world of actors that live inside here are also completely reactive and asynchronous. And when we introduce those kinds of systems, this is what we introduce: uncertainty. Right? This is what we really crave, don't we, as developers? This is what we grew up on: synchronous, order, certainty. Event 1 enters the database first, then event 2, and then event 3. Therefore, right, I will see and consume event 1 and then I'll see and consume event 2, and then I'll see and consume event 3. Forget about it. That doesn't work anymore. So uncertainty. You know, I found a great definition for the word uncertainty. It's the state of being uncertain. You know what though? I mean, I laugh at that too every time I see it, because that is literally a dictionary definition. But you know what? Here's what I learned from it. It's a state. Do you understand state? Do you? We deal with state all the time. We can reason about state. So uncertainty is a state that has the possibility to be reasoned about. It makes us uncomfortable in a lot of ways. There's unreliability, riskiness, and all these variables involved. But uncomfortable is a really good definition of uncertainty. Yeah, let's skip by that. Okay, so this is what we're kind of addicted to as programmers. We learned that if a client, and I'm not talking about a remote client and a remote server, I'm talking about two objects in the same VM, in the same process. And we have learned that a client can make a method invocation on a server object, and when it does that, the client stops completely until the server does whatever it does, and it might interact with a lot of other things back here, but finally, control returns to the client, and now we start running again. Doesn't that just feel nice? It's just, And then, the ordering addiction and the transactional addiction, right? Everybody get out of my database for a few milliseconds, right? I'm locking everything down so that I can write to it, and then I'm going to unlock it, okay? Then you can have it. Right? We're addicted to that way of thinking. So, thinking any other way makes us feel uncomfortable. But it's okay to feel uncomfortable. Have you ever felt uncomfortable about anything else in life? Have you succeeded even though you felt uncomfortable? Yeah. So, okay, we feel uncomfortable about reactive and asynchrony and the uncertainty of when things happen. Now, I think that it's a matter of perception. We can learn to see the multi-cores, and make good use of them if we learn how to look at them, how, that they are there, and how to see them. Do you know what this is? This is what's called an autostereogram. There are people in the audience, I will guarantee you right now, who see an image inside this. Are you one of them? Every time that I have shown this, given this presentation, at least one person in the audience sees that there's something cleverly hidden inside this audio stereogram. You don't see it? Nobody? Yeah, so what part of the solution to seeing this is if you kind of squint your eyes, even cross one or both of your eyes a little bit and blur, you can kind of detect, well, let me just tell you, there's a shark in there. There is a shark. Nobody sees it. No, there's one shark. It's somewhere like this is the nose and the tail. I think the tail comes up around here somewhere. Right at the moment, I can't see it. I have seen it before, but no, you think I'm joking. This is one of those American tricks, right? No, there's really a shark in there. Okay? There's someone in the audience who would claim that it's the markers that we use for the Sharpies, right? So that we're using for event storming. No. So there's really a shark in there, but it's cleverly hidden. Go look it up when you have time. Whatever it is, stereogram, and shark, and you can see on the internet that it's really there. They'll show you. They'll uncover it for you, and you can train yourself to see it. It takes a while. But you know what? I have a point with this. Believe it or not, this looks like the processors that were shipping 30 years ago, but it's way different. It not only has, a wider bus and more registers in it, it also has multiple cores. And by looking at it, I can't tell you exactly, but this could be one of those 88 core. No, it's not, because it's an i7, so it may be limited to just 24 or 32 cores or something like that. But if we squint and cross our eyes a little bit, and we stand back, can you see them now? They're there. They are there. But they're cleverly hidden, and we have to learn to use them, because that's the only way that we're going to write the software of the future. Okay, so what's the fortress about? So when we get into these uncertain situations, it's often the desire of those working in this uncertainty to create the illusion of certainty. And so what will tend to happen is we'll use these cool enterprise integration patterns called De-duplicator and Resequencer, and we'll create the illusion that there's no duplicate messages ever delivered, and that that messages are received in the order in which they occurred in the originating systems. So we build this fortress. Oops. And this fortress looks kind of like this. So here's the de-duplicator. So an event arrives at our microservice, our bounded context, and at the infrastructural level, we have this component that every single event or any kind of message that we receive, it keeps a backing store of everything that we've seen with some identity. Maybe it's a composite ID made up of whatever attributes are in this, and from that, we're going to deduce that if we see that pattern again that's already in our database, we're going to know that we've already seen that, and so we'll safely ignore it. Therefore, whatever the domain model eventually sees is certain. No duplicates here. Or if messages, maybe events, arrive latently, they're just arriving slowly, and some arrive earlier than others, and they're out of order according to what we imagine we should see, then what we do is we keep a backing store here, and we say, okay, I know that this incoming message that I've just seen can't be processed until I see this one. And then, what if this one is received first and this one second, but the second one hasn't been seen yet? We can't do anything yet, potentially, right? Or what if, that's really the case. If we receive, 3, then 2, then we don't see 1. So we keep this backing store, and we say, let's resequence all these messages as they come in, and we'll create the illusion of certainty. in a completely uncertain environment. These are two well-known patterns. Have you read about them? Enterprise integration patterns. De-duplicator, resequencer. Okay? You know the major problem with this? It's hard. It may seem easy. Okay, deduplication, that's kind of easy as long as you have a really unique, key that you can go by. But the ordering is hard, and you know what you end up with is this big database with a bunch of data in it that you're keeping around. You know why? Because you're uncertain of when you can delete it, right? How long should you leave the potentially duplicate messages in this backing store? Is a day okay? 24 hours? 2 days? 48? Is that good? 3 days? Let's call it 7 days. 7 days is good. We'll delete them when they're 7 days old. It doesn't matter when you delete them. 1 minute after you delete them, right? And the problem with all this, it's not only difficult and expensive and still uncertain, you haven't solved any business problems yet. Think about that. You're doing all this heavy lifting, you're doing all this crazy amount of work, and you're still not certain that it's actually working correctly, and you haven't solved a single problem right here, which is where DDD says, spend your brain cells here because that's what really matters, right? Okay. So yeah, here's the de-duplicator. Look at that. We see one again, so we're keeping a backing store to make sure that we don't let one through again. We don't want to let one through again. That would be disaster. Or, we saw 3, we saw 3, then 1, then 4, but 2 hasn't been seen yet, and until we see 2, we can't let any of this go because, what would happen if we process things out of order? Yeah. So what happens is we can let 1 through, but we have to hold up 3 and 4 until 2 arrives, right? Now try to explain that to your business people. Well, here's what happened, right? Walk them through that. They don't care about that. They just want the business to work. And it takes you hours to track down where this actually went wrong because as far as it shouldn't have gotten held up there. So this is what happens in our world, right? Stop everything. I need to be certain, okay, I'm ready now, right? That's just how it happens. But this guy here says, essentially in distributed computing, I have to tell you, even on a single VM, there is no now. There's this lurking bug that's global. It's in 2 major platforms. It's in the Java ecosystem and in .NET. You know what they are? Oops. Local time now in Java and date time now in .NET. They're just untrue. There is no now. As soon as you get a return value from now, it's wrong. Okay? So this is, I said this one time, I just made it up on the fly. People liked it. So I thought, you know what, if distributed systems are a problem for you, you should probably change careers because they're here to stay. Maybe open a restaurant. You know the replies I got? A restaurant is way more risky than software. and another one that, what was it? Oh, this is mine. Yeah, you'll still be using distributed systems, but you won't be programming them anymore if you start a restaurant, right? Okay. Yeah, so modeling uncertainty matters. How do we do it? Yeah, cloud, microservices, latency on the network, IoT, latency everywhere. All this stuff is cheap, right? So we got to make it work. Now, here's another important message. Alan Kay, the inventor of object orientation, says that the design of this inside is way less important than the design outside. What is the design outside? It's the names that we give these objects and the names that we give the messages that pass between them. So while we as developers have decided, by and large, that we want our objects to be solid, right? And I always fail to get these. Okay, so open-close principle, list cloud substitution principle, single responsibility principle. Yeah, inversion of yeah, and then dependency inversion principle. Yeah, that. Okay, so we want our, now imagine, right? We've got this totally solid designed object. And the communication between the objects is completely unclear to the business. It has technical names. It has a completely technical motivation. And we try to have a conversation with the business and explain what's going on. And they don't understand. Everything that we tend to do needs a translation to the business. Well, you know, you stop them. No, it's not a product here, it's P, right? We call it P. So the communication on the outside, the inventor of object orientation said, is more important than the design inside. He says, you know what? Inside is way less important than the communication outside. And you know what he refers to it as? Ma. Does anyone here speak Japanese? Do you know what ma is?
Well, if it's two ah, then it's either in between
Yes. Yep.
or it is well. But that is
It's the first, yeah. So what Alan Kay meant is the first one. It's what's in between. So he said what happens between the objects is more important than what happens inside the objects. So look for the space between the objects, and if that communication is unclear, in essence, according to the inventor of object orientation, you haven't done a good job in your object design. Sorry, I'm just the messenger. Okay? And thank you. I think you're the first Japanese speaker that can actually say that I understood what Alan Kay said. Okay, good. Thank you. Okay, reactive systems are a real thing, state of being uncertain. Okay, now here, have you read this paper by Pat Helland? Pat Helland was like one of the wizards of global transactions, right? He was writing XA drivers. He worked for, you know, in big computer companies that solve problems with global transactions. And Amazon hired Pat Helland and said, make this grand e-commerce system scale. And Pat Helland came in and he was using global transactions and he realized it won't work, right? This is like, you know, one of the wizards of, and so he wrote this paper called Life Beyond Distributed Transactions, where this person realizes this simply won't work. And here's what Pat Helland said. He recognizes that there's uncertainty in distributed systems. In a system that cannot count on distributed transactions, so there may be still some systems that can correctly use distributed transactions, Pat Helland says the management of uncertainty, that is, not knowing what's going to happen next must be implemented in the business logic. Yeah, Pat Helland. You know, that's a DDD statement if I've ever read one. So what Pat Helland proposed is this idea of an activity. And Pat Helland says that between any two entities in a system, there are activities that occur. And when something happens to this entity and it is a partner with another entity, this entity will have to be compensated through an activity that is caused by this entity over here. And so Pat Helland says what this entity needs to do is track the activities that have occurred between the two, so that it originates here and ends up here, and this entity is going to keep track of what happened through this concept of an activity. And the activity says, I've seen this or I haven't. If it's there, I've seen it already. If it's not there, I haven't seen it yet. That's a good principle to go by because that actually solves both of the problems we've been talking about. It's still a little technical, and I'll explain why I say that, but think about this. If we have seen the activity occur, let's call this entity one that was the cause, and this is the effect over here, right? The impact. And entity two has a record that this happened. It means that if we see that stimulus arrive in entity two again, we can ignore it. It's a duplicate, right? And if the activity requires more than one step to complete, we have a record in the activity that says we've seen, for example, 3, and then we saw 1, but we haven't seen 2 yet. Therefore, we cannot carry out the end of what 1, 2, and 3 will result in until we see 2. Okay? Very simple logic. But here's sort of the problem that I see with, it's not a problem. I'm not criticizing Pat Helland, but this seems like a very technical solution to me. This is what I see in my mind when I read his paper about what an activity is. I see a class called partner activities. That's what he talks about. And internally, I have a set of partner activity. Right? This is a specific thing that can happen to me, this entity. And I'm going to record from a partner an activity that occurred, and that becomes a partner activity that I am going to add to my set of partner activities, right? And then, somewhere along the line, I may need to ask, have I seen this partner activity before? If I've already recorded it, then I have, and I'm not going to do it again. And if this particular kind of partner activity requires some kind of sequence, then I can also record, my partner activity internally may actually record individual steps. Now, that's fine, but again, it doesn't really address any true business needs. Internally in the entity, it still is very technical. It feels like an artifice to me. So I want to think about this in a different way. And DDD says, okay, we're going to do this here in the domain model, but if we do it in the domain model, it has to adhere to our ubiquitous language. That is the whole point. So we're going to create part of our language to state that these things have happened or require a completion, or a sequence to reach completion, and we're going to do this in the domain model, okay? So all these messages flying around is going to result in a solution, and I'm not going to step through that. But here's a basic concept. A named entity, call it product. This is a product, in order management. It's not a product that we're about to purchase that's in our shopping cart. It's a product that's in order management. And this product in order management is tracking things, steps that have occurred, and it cannot finally capture the money from a user's credit card until we know that the inventory is actually available and has reached the dock, the shipping dock, right? So in this case, we see potentially multiple commands or events being redelivered because of the problems that we have with messaging middleware and, you know, network partitions, hiccups, and down servers, and all, you know, anything that can possibly happen. Just add more nodes, you'll see it happen. And this entity receives a stimulus and it says, you know what, I've already seen it. But this is not called partner activity. This is called product. And this state that we've already seen could be from the shopping cart. We had 5 products in the shopping cart, and that's what the user said, I'm purchasing. And their credit card has already been, you know, what do they call that? The authorization stage. I don't have all that terminology cached right now, but I think it's, you know, they get authorized that yes, this money is available, so they can go to the next step and start to see the inventory actually taken off shelves. But once it reaches the shipping dock, we see that this particular product was shipped. Now, if I see that that particular product was shipped multiple times, which can happen, I don't want to go capture the funds multiple times. That's not legal, right? Well, okay, it's a mistake, but how many times do you want to really anger customers that way? So the entity state sees that the shipment has taken place, and it's actually waiting for all 5 of those products to occur. So part of it is deduplication, but part of it is, have we seen all 5 of those products taken off the shelf, put in a box, and sent out the shipping dock? That's a different problem, right? But again, this entity is named product. Until we have, you know, let's take this situation. Let's just say that we finally do capture, right? Now, in the product management itself, this product is not going to capture, but it is going to emit an event that says, we are at the, you know, in essence, that triggers in the account system, the account service, that this can happen, okay? So what do? We emit an event that says this can happen. What would happen if we saw any stimulus arrive in duplicate and we emitted this event again? Now we have to be careful that, you know, whatever is downstream from us doesn't react to this multiple times. Wouldn't it be great if we could ensure that that only happens once? Okay, so that's the deduplication problem solved. And there are different, you do have to keep track of one thing. You know, some events that come in, or commands, result in operations that, if they were to happen in duplicate, would cause big problems. Like, just think of a bank account. If the withdraw arrived twice, and you did actually withdraw twice, you know, and the person only received the money once, that's a big problem. So you may have to keep some, not only a state, but the state may have to include an identity. Because what if they did withdraw twice in one day? Each of those transactions has a separate ID. So you can't just depend on the informational data itself, as in the values, it could be identity that's important too. And then we have the out of sequence problem, right? 3 arrives, then 1 arrives, then 2 is latent. Notice we've recorded that step 1 occurred, and we recorded that step 3 occurred, but we're not going to take a final action until step 2 occurs. Again, remember, this is product. This is not partner activity. This is product. So here's what happens. 2, in whatever case, arrives, and we finally have steps 1, 2, and 3 that have occurred, and the product now safely says, I'm in a completion state. I can now emit the event that says the entire order, for this particular client or customer has been fulfilled through the fulfillment. It's all reached the shipping dock. We had, inventory for all of this, and we're going to say order filled, right? Finally, order filled. That's the end game. But it solves another problem too. Think about this. What if 2 never arrives and we don't have a Z here? Instead, we have blank. If this entity is designed as an actor, the actor itself has the ability to set a timer that says, we're going to say that if we haven't seen fulfillment of this particular product shipped for this order within 10 minutes or whatever, maybe even it's a few hours in e-commerce, it also means that there's another business step to take. We don't unwind all this and say, compensating transactions everywhere. Take that box, take the box off the truck, put it back in the warehouse. We've rolled back, right? Come on, what? Right? You always want to sell when you can sell, and if you can sell 4 out of the 5 products right now, you're going to sell the 4 out of the 5 products. We're not solving technology problems, we're solving business problems. Try to convince Jeff Bezos not to sell the other 4 products, right? What's going to happen is in a few hours, wherever this happens, maybe we don't ever see step 2, but we see another stimulus that says inventory unavailable, or we don't see anything at all, and we simply make the assumption based on business understanding, business knowledge, business decision that says this order has not seen a delivery or a fulfillment of this particular product, therefore we're going to send a notification, an email to the customer and say, we're evidently out of stock on this. Would you like to cancel this part of your order? We've already shipped the other 4 items. Would you like to cancel the other part of this order, or would you like to wait until it's in stock and we'll ship it to you in stock? Otherwise, we'll refund you the money for this one item right now. Well, there's also potentially the case where they do need all 5 of the parts, but it's now the customer decision, not our technical decision to roll back. And if the customer says, I'm canceling the entire order, well, we can take care of contacting the courier and saying, don't deliver this particular box, right? And we'll refund the entire order. So but these are all business decisions. These are not technical decisions. And DDD says we have to consult with every single, on every single step of the way to define what are the time frames. What is the business process that if this happens and this doesn't happen? And you know what? The corner cases are where you win. Yes?
I just wonder what the difference between this and Saga.
Well, this could be controlled by a Saga. But a Saga has, the definition of Saga is different than Process Manager. Process Manager says, typically, we don't roll back in the sense of compensating transactions. And I think this is more of a process management, but it's very thin. Notice that we're not emitting commands as a result of seeing, so we see this event from the outside, we translate that into a command, let's say, right? And it enters here. Well, we're not telling other things to happen. We're simply emitting an event if the other things happen, right? The final conclusion is order filled. But a Saga, so you could call this a mini process, but it's really not running, it's not telling other things what to do. It simply said, originally, order created, right? Or order placed, which is even more of a business term. And then eventually it will either say order filled or order partially filled, for example, right? So that's the difference. Okay, and then this same sort of logic can be used to deal with things like, okay, I'm gonna wait and see where some product is available in a warehouse in inventory, but I'm gonna select the one that's closest. So I'm emitting an event, or someone has emitted an event that causes all these warehouses to say, I got it, I got it, I got it, right? And if 3 warehouses have it out of the 15 warehouses that could have it, then the one that's closest, whatever closest means, to the customer is the one who's going to get the job of delivering it, right? So you can use the same line of reasoning for that. And then also the multiple choice, as in the first, the fastest, right? I don't care. 2 showed up first, it's close enough, let's use that one, right? So the where is a 1.3, could be better than that, but hey, they're ready to roll, let's go with that one. Well, here's the process manager. So this is the difference. We have this central, this is really an entity for all practical purposes. But when other entities emit events, the process manager is going to listen for certain events, and it's going to issue commands. So it's the opposite of an aggregate, in that aggregates intake commands and emit events, right? This is seeing events and emitting commands. So it's directing, do this next, do this next, do this next, right? Until we finally reach. So this could definitely be an order manager, but some order management can be managed just through essentially one event outgoing and multiple events coming in. Depends, right? Okay, so yeah, time matters, and I think I'm probably pushing my time. And Trond needs to put his kids to bed, right? So, sorry. Okay, time matters. I already explained that you can have timeouts, but here are some modeling heuristics to keep in mind when you're dealing with this situation, all right? You don't own the time frame. Here's what happens. If you're the CEO and you say, okay, the timeout is 5 minutes, and your largest customer comes back and says, shouting, why didn't I, and the CEO says, we got to tune those numbers a bit, right? If you make that decision, you know what you get to tune? Your CV, right? That's the difference. We don't own the time frame. We're developers. We're not the business. But we want to have a close association with the business. Be uncomfortable, but make decisions. This is an uncomfortable situation. We don't know what's happening, but you have some very simple tools to solve this problem, and you're solving business problems over technology problems. Right? Did you understand? I hope you got that. I hope you got that. And start with what you know. So, what do we know? Well, we got an order. Order was placed. What happens after the order is placed? Well, here are the steps, right? We can logically go through the steps, but interestingly, many of those steps don't belong to us anyway. We're just managing the order to the point where we recognize that the order was either completely filled or partially filled, but all the other bounded contexts or microservices are essentially reporting back to us saying, okay, this step succeeded, this, and now we get to the point where we can say order filled, or we time out on something and say order partially filled. You know, we've fulfilled our responsibility. Our service works. We've had uncertainty about what could happen, but we've dealt with the potential for not knowing what will complete or when it will complete or if it will ever complete. All right, so that's all I had. Oh, one thing, yeah, man, I didn't talk about this at all. So please look at my platform that's under development. It's open source. It's called Lingo. The part of the word is lingo, which is a pretty good clue that this is going to be very helpful to DDD developers, but the foundation of Lingo is, of course, actors, okay? And right now there's available a cluster for Lingo, which is a cluster, any cluster of actors, Wire, which is really just a set of tools for full duplex communication, whether it's UDP or TCP, Directory, which is service registration and discovery, and what else do we have here? Yeah, and HTTP, which is making REST interfaces really, really simple. Implement a REST interface in seriously 5 minutes. Okay, so keep your eye on this. This is happening. I predict that companies will be using Lingo in anger by summer. Okay, so that's all I have to say. Thank you for attending.
All right, almost everyone is still here. For those who don't know me, I'm Alexei. I am organizer of DDD Norway meetup. So thanks to Freddie to have this combined meetup. Thanks, John, for coming, and Vaughn as well.
Thank you, Alex.
Exactly. Yeah. People, let's give a hand to these people, right?
John will be giving a second talk now. So before that, I would like to tell you that the next conference in Europe about the domain of design is DDD Exchange. It will happen in London at the venue called Skills Matter. It's a very good conference. It's not that as big as DDD Europe, and I know I've seen a few faces there. So if you like more intimate atmosphere, like about 200 people, like 3 times less than Amsterdam, enjoy London. So come over. I will be speaking there as well. And Thomas, who is here? Are you here?
Yeah, I'm here.
We'll be speaking there too. And but if you don't go, we will have a meetup again in either end of March or beginning of April to rehearse on you. So Thomas and me, we will have a combined session to do end of this month, beginning of next month. But we recommend going to London. So look at skillsmatter.com. Many people will be there, many speakers who can hang out with us and have a good conversation with fellow participants and speakers as well. So now,
and you're recording this
I'm
event?
recording this session and I will be editing it a little bit, just putting it over basically, and publishing it online on YouTube. So it's mainly raw video, so don't blame me, but I'll do my best. So it's very cheap equipment, but it's proved to work, and everything should be fine. So John, give him a hand.
I'm going to use the idiom now. Vaughn Vernon. Left. Okay, it wasn't that important. But yeah, there is a Norwegian idiom called jumping after Virkela. And you may say, well, you know, it's big, of course not what this is, but there's actually English wiki page on it. So you can look it up for all your non-Norwegian speakers as well. So that's what I'm doing. I'm jumping after Vaughn Vernon. Yeah, and I also want to do it before I start. I want to do another shout out. Do people know what kind of day it is today? Hands up, those who know. Good, not bad. I want to give a shout out to the women today, because this is the International Women's Day. And how many women are in the audience here? Hands up, please, so I can see. See, there's a handful, maybe a little bit more, so not that bad. But this industry, we need more of you guys, right? And you guys, we need to make this environment that will thrive in, right? So let's make that a sort of New Year promise for ourselves, okay? Okay, hands up for the girls. So let's get into this. The reason why I started digging into business capabilities or capabilities in general was based a little because I've been doing SOA for it. And it's the Udidahan kind of SOA for the first people who know that. So it's not the Thomas Earl thing. And there's a lot of reference to capabilities in that model. So I needed to sort of, and I got into it because we had a project a few years ago. We wanted to split up a monolith. I guess a few of you have tried that to start, or maybe still doing it. And the capabilities and the services came up as a way to do that. And this was before microservices, by the way. We did it in 2014, I think it was. And we need to figure out how we should split this monolith. And then I started digging into the capabilities. So this is basically me sharing with you what I've learned in that journey from 14-ish and from today. And it's also nostalgic, just as Vaughn has been earlier doing referencing to Hewitt and all the actor models and all that. This is also a bit nostalgic and looking back, technology. So, but before I get into the capabilities, I want to actually do, since this is a domain-driven design talk, let's do a little bit, because to be frank, capabilities are more SOA than domain-driven design, even though they do match quite well. So I want to start off with some modeling first, and architecture. I'm probably speaking to the choir, but most of you probably see the worth in doing modeling up front, at least some modeling. Even though some people would either say that you shouldn't do documentation, you shouldn't do bigger front-end design and all that. Reference this to this. This is Alberto Brandolini who's quoting Matthias Veras here. This guy, which Alex just mentioned, which is the guy behind Domain-Driven Design Europe. And what he's saying is that big upfront design, we all can agree that that's probably not a good idea. But what about big upfront discovery? So we need to learn, dig into the domain. We need to spend time doing that and not building big diagrams and and architecture models and all that. Just learn the domain, that is what his sentence is. So, and the main idea behind this is, and that's probably Eric Evans who said, I don't have the quote from him, he said something like that, that you can't, yes, you can create a system and your solution based on the requirements alone, but you probably won't be able to make a sustainable solution because you haven't necessarily aligned it to the business, and then you're not probably not equipped to handle the changes that comes in. You're not adapting to the changing business domain. So the main idea is that architecture and all we do is just a lot more than just tech. Like we do modeling, we need to do a lot of modeling, and not only one. If you've got one model, you have a big risk of choosing the wrong model. So you need a lot of models, handful even, maybe more. Be creative and challenge your models and don't get too attached to them. It's the same as they say with cloud computing is the servers are no longer your pets, they are your cattle. The same thing. You should treat the model just the same way. Right? Make a men's model that you actually treat them as cattle. So you can throw them away without feeling that you're hurt or that your big plan was destroyed or whatever. Here's another one from Alberto. This is directly from Alberto then. And this is something that has occurred to me in the last few years, at least since 14. That is, coding is not what we do most. Yes, we are coders, we are programmers and all that. But when I look at my day, at least when I really did a lot of programming, there wasn't that much production code I created. So there is more we do a lot more than just writing code. So what is it? It's the digging in, it's the learning process that we do. And also Dan North had a similar point where he said that learning is the constraint, not the writing of code. Whereas Kevin Henry said, typing is not the bottleneck and all that. Right? It's not the code that is necessarily the problem. So we need to understand the purpose of the software we're making, and doing that we need to model, we need to understand the domain. Yes. By the way, I had to Google this. Anyone familiar with Brandolini's law? What's that? Anyone?
The bullshit asymmetry?
Yes.
Oh, okay.
Okay, I'll read it out here so I don't miss it. The amount of energy needed to refute bullshit is an order of magnitude bigger than to produce it. That's Brandolini's law. And you know what? If you Google that in Norway, in your papers, you're going to find a lot of reference to it. Brandolini's law. So he's probably more famous outside the community for that law than what he's doing in software. But, yeah. Yes. I do another quote from this guy, Peter Drucker. He's probably the most famous management guru in the world. He said something along those lines. I'm not exactly sure of the quote, but I'll get to that. Management is doing the things right. Leadership is doing the right things. And this is where I think we should be, the latter half of that. He also said, this is a good quote. There's surely nothing quite as so useless as doing with great efficiency what should not be done at all. Have you done that? Have you created a lot of diagrams, a lot of constructs and all that, and just finding out, yeah, true that. Probably the project never happened, it wasn't great, all that. I think a lot of effort doing this, and we spend a lot of time doing effortless things, or things that doesn't matter. But I want to, probably what you have heard before is this one, man. It's more important to do the right thing than do the things right. It's not a direct quote, but it's sort of summarizes his views. That's the theory. So, I think it was Einar Høst, is he here today? No, he's doing a talk on NDC about technical debt is not technical. And his idea is that the major problem we have with what we're solutioning is that we actually choose to solve the wrong problems. So the problem, the technical debt is the domain, the misunderstanding of the domain or not understanding the domain. Recommend to go to that talk. It's really good. There's another quote. I do a lot of quotes today, sorry. But yeah. This is, anybody recognize this guy? Oh, it's there. Ray DeBooch, the father of UML. His definition of architecture is something that resonates with me, though. So first, architecture is design. So I've started using design a lot more when I talk about architecture than actually saying architecture. And architecture represents a significant design decision that shapes a system, where significant is measured by the cost of change. Can you think of another big cost of change than creating the wrong thing or creating the wrong thing based on your wrong domain model or domain understanding of the domain? It can really lead you down the wrong path. So, for example, I think one reference is the wrong band. If you do the wrong boundaries, for example, if you end up creating an idea that you've got a context map or you've got a domain model on bounding context, and you got a sort of rough idea of what these are, and you start breaking things up based on them. And it ends up that the bounding concepts are wrong. What are you doing then? they are not probably not loosely coupled, and you can end up going into this distributed monolith, but also one reference, right? Where everything is coupled. You have a lot of complexity when there's a lot of small systems that are interconnected. You want to avoid this. And my impression is, because I did it myself back in the day, as I mentioned, in 2014, we started with that idea of how we should split that monolith. And it proved to be not wrong, but we okay, we couldn't do all the effort of mapping this, so we just started. Okay, let's choose the low-hanging fruits. We do this building component, let's do that, right? And you start, what you're actually doing there is that you're getting onto a slippery slope. If you don't have a plan or a map, I'll get back to what a map is later on. If you don't have an idea where you're going, this can be really, really, really risky. Because before you know it, you have so many microservices that you can't see the end of it. 200, 2,000, whatever. Right? So you need to have an idea where you're going. Yes, back to maps. Anyone familiar with Wardley?
Yeah.
Yeah. You went to the main design in Europe, sure. We had a great talk there. This is something I've just started looking into. I just started looking into it a year ago or something. I tried some mapping, failed for the presentation I did in Europe, thought maybe I should try again. So I probably will. But his idea is that you should treat, this is strategy by the way. So you start with a purchase from St. Louis 5 factors. You start with a purpose. You know your landscape, you take reference to the climate, you set doctrines, and then you start doing applying leadership. This is how you win a war. It's after war from Sun Tzu. And what the main point that Wardley makes is that we do a lot of this, and even this architecture principles and all that. We do very little of this and nothing of this. We don't understand the landscape, he says. We don't understand our competitive landscape or domain or whatever. And we have no idea of what is shaping what's happening around us. So he's created these Wardley maps that is supposed to solve a little bit of that. That's what I'm trying to look into. So maybe later on I will give a talk about it. But the main point is still there. You need to understand the domain and the competitive use. I don't want the one regular bush. It's not really him I want to reference. Just somebody who looks like him. You know, I guess you all know who this is. Anyone? There is, yes. Okay, check. You know who this is? Yes. I will really hope somebody will get it. It's a more old favorite of mine. I come from a science background, astronomy, and I really was fascinated by Galilei. So why do I pick up these old guys? It's because they were known as the Renaissance men, right? The polymaths. And I'm not saying that we should be as smart as these two. Then again, maybe some of you actually are, because they worked on in a time where very little was known, so it was really easy to get a broad picture of a lot of stuff. Today we can't. We have to specialize in one specific thing. But we as developers, we start off as developers. Then somebody came along and said we should do some ops as well. We should collaborate with the ops. So you have the DevOps culture. And now I'm trying to advocate, and you probably are as well, that the developers should understand a lot of architecture. Because you have agile teams, the agile teams should be able to find their own architecture, and especially be responsible for their own architecture. And if they understand the domains and everything, then maybe they even need to be closer to the domain, not necessarily in the domain, but they need to understand it. So maybe you should have something else, something like that. And I think it was Dave West at the last year's the DDD Europe, was it? He had a presentation where he referred to these polymaths, and he said that before we had system engineering, it was the domain expert or the business that did the program, and then I realized I couldn't continue that, so they split up. I'm not saying we're going back to that era, but we need to understand more of the domain. That's what I'm saying. So another quote. And by the way, anyone have issues with this quote or this slide? Not you. I don't have to say anything. There's something wrong with it. The quote is correct, but It's not he who said it. Right. Just saying. But the code is good nevertheless. And this is also something that Dan also talked a lot about, is that we are back to the learning is the constraint. And he says that ignorance is basically our time killer, is that we don't understand what sort of problem we're going to solve. We have to spend a lot of time on that. And also, we as human beings are fallible. We have a lot of biases, we have a lot of fallacies that we run into. Just on a list of examples, we do a lot of cherry picking, and we're gonna make proofs to ourselves. We do a lot of anecdotal evidence. We do a lot of false consensus. We do a lot of survivor bias. We see, okay, this worked. Of course, we work there. Then of course, going to work again in this context, of course. And you got the IKEA effect, or not invented here. You created it. It's mine. I'm proud of it. Right. Back to that thing. Now we got echo chambers. This is maybe a little bit what we're doing here. Human design. So we need to be careful about it. And that's why I really love, I can recommend for all of you Domain Driven Design Europe. Yes, it's bigger, but it's broader. It's probably the best architecture conference I can think of. I'm probably not going to stop going there unless somebody keeps me away from it. Because it's so broad. It's a lot more than Domain Driven Design. Because this is architecture, this is design, this is everything. So, okay, I have to get into the biases that probably troubles us the most, and especially and myself, is the confirmation bias we have all the time. Is anyone familiar with Dunning-Kruger effect?
Oh, yes.
Yeah. Have you experienced it yourself? Have you seen yourself in there?
Of course.
Yes. What part of it? The latter part where you understand more and then understand how little you actually know, or the first part?
Both.
Yeah, because a lot of people start to make bold claims from the first part, then probably never even come to the latter part. I'm not saying other architects do that, but it could be. And myself, as I said, I have a scientific background, and I try to live, but I don't know if it's a saying or whatever, it's a quote or whatever, but it's a strong opinion held weakly. I have a lot of strong opinions, but I'm willing to change at any time if there's evidence against what I'm believing. Oops, sorry. Before I start, this is a terrible resolution. Just an example of myself doing this whole confirmation bias or not understanding of general truth or whatever. I had a talk a couple of years ago where I said that we do microservices and Agile and all that because it was need for speed. And yes, it's not wrong, but it's missing the most important part. We're doing it for maneuverability. We need to be able to adapt to change to the business model. That's what we do. So, with that in mind, have a look at this. Which way does the train go? And you can actually, if you look at it, you can actually choose which way you want it to go. See that? You want it to go towards you and go back. Just an example how easily we are fooled. So be aware of those biases. So let's get a little bit more into what I'm supposed to talk about here, which is business and business capabilities. The whole idea with business capabilities, the basic idea is that business capabilities is what's going to get us closer to the business. I have a little bit problem using a yin-yang symbol, so I just throw up a little bit in my mouth doing that. But it makes the point though, right? There's a tight connection here. The business use the IT to drive their business, and IT enables the business. So it's very tightly. So the whole idea here is that we need alignment between the two. Judith Hahn had this figure in a brilliant post, which I recommend you to look up. EDA, so what should the looking glass? Used to be an MSDN, but somehow MSDN has chosen to delete a lot of their stuff. So I think it's on its webpage now. But anyway, this is to illustrate that you have a business domain and you have apps or solution domain. They are not aligned, so there's contention and inertia all the time. When they want to make a change, they have, this is a simple diagram. If they want to make a change, they have to make change to loads of different components that they didn't even know of. it doesn't reflect their view of the business. So back to this, one simple change here should be a simple change in IT. Then you are aligned. And he illustrated the alignment like this. And of course, he's service-oriented guys, so they are called services in this world. Yeah. Okay, I'll do that. Have you somebody read the Jeff Bezos? He puts out some letters once in a while, each year or something like that. He talks a lot about day one. And I think in there you find probably the secret behind Amazon's success. By the way, Amazon is probably going to be the worst company to get to 1 trillion. I'm sure it's going to beat Apple to it. Why? What is their secret to success? It's that they never go to day 2. They always stick to day 1. They're always a startup. Everything they do is based on a startup mentality. Right? So the business are aligned with the service that they create. So now we're getting into capabilities even mentioned here. This is a quote from another great post by, the name is Siriam Narayan. Is that products mode? This is the paper is about product mode versus project mode. Projects, then you control all the solutions that you're going to create, and it's cross-domain probably sometimes. And product modes that you define your solutions and your organization around projects instead. And he says that products mode work best when teams are organized to be simultaneously aligned with the business relevant capabilities and with enterprise architecture boundaries. He followed up the code saying, without the former, they may lose alignment with the business goals. Without the latter, they lose autonomy. So this, when I read that, I sort of sort of appeared to me that business capabilities might be really something important. I mean, people have talked about this for years, but it took me some time. So what we're actually talking about is modularity. And I always, when I talk about modularity, I always pick up this paper from David Parnas, which said, the effectiveness of modularization is dependent upon the criteria used to divide in system into modules. That will be doing. But there's a risk here. As I mentioned earlier, when you start splitting things up, there's no guarantee they're not going to end up like this. You break things apart, you put piece by piece, and you get shards. They're not working, they're hurting you in the long run. So we probably, and as I mentioned the slippery slope earlier, so what we probably want to do is something like this. This is from me, that was part of so it was in Trondheim. We do have a map, we need to be careful. And we need to look at all these important characteristics like autonomy, isolation, cohesion, loose coupling, authority, and all that. We need to have a plan. That's what I'm saying that again and again, and a map. And all this takes hard work. Like we all know, second law of thermodynamics, entropy always increases. And weirdly enough, we tend to do that in software as well. If we don't take care and mend it, it's going to end up easily like this instead of like that. Right? And I'm still not saying that you can't have a bigger front model, but you need to understand so you can create that. Another topic I'm trying to look into these days, which I think there's a lot of learning to do, is system theory. Or thinking in systems like this. I got recommended this by someone on Twitter, I don't understand it. I bought it, started reading it. I think there's a lot of knowledge in here. Because what we are basically doing when we're creating this, we have a lot of small different parts that works as a whole. That's a system. And if we have a lot of them, and there's a lot of connection with them, we have a complex system. And with complex systems, you have emergent behavior, things that happen that you didn't anticipate. And when we don't have a plan, these are going to pop up everywhere. I'm not saying, and I think there might be some secrets in there, so hopefully when I get time to really dig into it, there can be some insights to learn here, to find out what this is. A good example of a system thinking is that when you do local optimization, it doesn't mean that that's going to be good for the whole system. If, for example, in some area you decide, okay, we're going to do Scala because we love Scala and we're going to always do that. Fits perfectly with that domain, but unless that's isolated, it's going to affect the whole system. So the whole system may actually take damage from that choice. I was also a talk by Mr. Dave Snowden at the last domain design job, where he talked about complex adaptive systems. We have a complex system, yes, but they are adaptive. And we are, inside we are a complex adaptive system. We're complex, we adapt to changes. And that's what I think, so there are something here that I think is worth digging into to understand how should we design our systems to be adaptive as well. So a lot of stuff about modeling now gets into what business capabilities really are. It's about, as I mentioned again and again and again, it's about having a plan, having a map, so knowing where you should go. And business capabilities are nothing new. This has been done in the business for ages, since the 60s probably. But it turned in, it emerged into the business domains in the 90s, I think it was. And it ended up in the architecture frameworks, which you all probably know. Toga, for example, has this. But it's really only, or not only, but it's focused on the business domain. It's finding what are the business capabilities of the business. What he did, which was a revelation to me when I did his course back in 2012, I think it was, is that he made this thing. A service is a technical authority for a specific business capability. I didn't think much of it back then because I didn't really understand what business capability was. But okay, something businessy. It's not some alignment with the business reference. Think about the figures I showed earlier. Right? But there's profoundness in that book. That's what I'm trying to get today. Yes, so let's get back in time. When I started digging, do some Googling and all that, as we do, we end up in the dark corners of MSDN, Microsoft Developer Network. Right? I don't know how many people here are in Java space. Have you ever visited MSDN? Oh, not that bad. It took me some Googling to actually enter this. And this figure is not relevant right now, but it is from one of those business capability papers. But the funny thing is that figure was part of Pat Helland's paper 2 years before this, 2004. Or maybe not this paper, but this blog post that he created based on the paper, which is longer, but sadly also removed from MSDN. I got a copy if you want it. Yeah. So the whole thing, so what Microsoft probably did then, back then, was that they took the concept of business capabilities and joined it with services. That's my thesis. That seems like, I seem to get confirmation bias in that, I'm not sure. But it seems to be a thing that they did. And they also created a framework called the Motion Framework, which is the Microsoft consultants services used a lot. But I've never heard of it, but I was in Java space, so that's probably why I didn't. And it probably culminated, at least as what I can gather, in this book. This is actually a book. It's you can download it from InfoQ, so it's basically a thick paper. So it's not done. But he describes how you should do the business capability modeling. This was in 2006. So, but after that, nothing really happened, at least as far as I know, for a few years. And why? Maybe because it was something that the EA did, the IVR architecture, enterprise architecture did. I met a colleague out here. He's just been here doing a workshop for some people, and he's doing an enterprise architecture workshop. He knows very well about business capabilities. I hadn't heard of it before I went to that DDD course back in the day. So, so why is this? Maybe the same problem that domain-driven design has struggled with. Is that it takes a lot of effort. There's a lot of logical thinking. There's a lot of non-technical stuff you need to drill into to understand, to get the domain design properly. It could be that, and Eric Evans had said that that's why he's structured the blue book the way he did, because he wanted the developers to get into this. But the problem is the developers, yes, they did get into it, but they didn't read all of it. They stopped halfway. When all important advanced, or not advanced, but difficult stuff came, I understand it now and put the book away. And this might be why what happened to these business capabilities and so on as well. I'm not sure. But anyway, a few years, actually, a couple of years ago, I came across a presentation by some guy called Ulrich Kalech. He now works for the Open Group. And then they came with a paper last year, I believe it was 2016, 18 now. Yes, a business capability represents the ability for business to do something. Now we get into what a business capability is. This is a good definition of it. A business capability is a particular ability or a capacity that a business may possess or exchange to achieve a specific purpose or outcome. I'm not sure if this gets crystal clear for you by these quotes, but let me try to explain. A business wants to reach a goal. They want to reach either an audience or a customer segment or whatever it is. They need to have capabilities to do that. Those are the ones that we find out. So it's not how they do it, it's what they need to do. That's the essence of it. So the business capability is all about the what and not the how. That's what makes them really interesting, to me at least. And also, that's why you need to model it. You can't create solutions for it, because you wait with the how. You need to understand the how and what first. You don't even have to understand the why. The focus is on the what. And it's not on another aspect of this, it's really static, and it's structural, and it's top-down. You start with they define levels of the business capability model. So level 1, level 2, level 3, or maybe level 4. If you go further than that, you're back to functions. So you have to keep it up to top level. And why? This is one from Bill Poole. It's another blog post I really recommend you to read if you're into SOA. He wrote it in 2008 and stopped. Nobody knows why, but there are a lot of insights in this series of blog posts. Hope they never take it down. But anyway, he refers to the value chain analysis here. And value chain analysis comes before capabilities. That's the earlier concept, but it's basically the same thing. Or at least that's what he refers to. I had to dig into this. This is a tangent, but value chains. In a lot of companies I worked in, they always refer to value chains, and especially in telecom, they talk about value chains. And that doesn't resonate with me. Value chains are old. That is like you have materials in, you do something, and you sell products out. In telecom, you don't really sell anything. You provide it to people, and they use it, and you have to maintain it. And there's a lot of stuff that's not covered by the value chain, per se. And I found a few papers by actually a couple of Norwegian guys who said that there's more to this. Value chain, yes, that's one. That's production of resources and all that. You also got value shops. It's when you go to the doctor and you got yourself checked up. That's not a value chain what he's doing. He's talking to you. You interact, you discuss, and you find out what solution how to get. That's a value shop. Like NAV here in Norway, same thing. And in telecom, what's that then? They refer to this as value networks. What telecom is doing, they are creating services for you so you can interact. So the whole idea is to keep the network up. If the network on Telenor, if you can't call anyone, you can't message anyone, you're losing customers, right? So it's really important to keep that up. And that's not a value chain, that's a value network. But anyway, I digress. Right back to this. So let's view this as business capabilities. They are the starting point. Then, based on that, you create business processes. Then maybe you start creating roles and organizations and KPIs and all that, and then organization again. So what you see here is that this shows you the level of stability. This is stable. This really rarely changes. This you can change a lot, depending on strategies and all that. That changes a lot, and that changes a lot, you know, right? Just went to a reorganization at the client I'm at now. The idea is that these are the most stable thing you can find in the business. The business capabilities are the stable one. If the company decides to do something new, yeah, that's a new capability. And then you need to create systems or services for that new thing. Or you can say that, no, we no longer want to do that. That's not strategic for us. Then you remove capabilities. But over the whole enterprise thing or the life of enterprise, these are really stable. It's not like Telenor stopped doing text messaging, for example. Maybe they do sometimes. They do messaging, they do interconnection or something like that. These are stable things that they provide. Yes. So let me define the capabilities. Now it's a lot of bullet points here now, but I need to do this. They are, as I said, stable. They are cohesive. That's the idea of them. They are self-contained. They are not directly dependent on others. They might be influenced by us, but they are self-contained. They're independent. They work on their own. And they're hierarchical. That's a tough one. And it's not necessarily strictly, but it's a very good model to use. That you have a top level and a second level and third level. You break it up into the hierarchy. I can show that afterwards. An example of that. And what they're not. They're not a department. As I mentioned, as I showed you earlier, the organization was all the way to your right. That's unstable. Capabilities, value chains, stable. So they are not a department. They're not a business process. And that's probably one of the issues I have with business capabilities. They don't capture the business process. You need to model that outside of business capabilities maps. But yeah, so they don't capture that. Because the business process goes across the capabilities. Then not a function, because that's all the way low. If you go to level 4 or level 5, maybe you encounter the functions. But before that, they are not the capabilities. And this one. I see a lot of people modeling today. and I really liked the post by Michael Nygaard a year ago. It's sort of about the problem that we model with entities. We have a product, we have a customer, we have an account, and we create services around those. But the problem with entities, they are not capabilities. Capabilities share, entity is shared by a lot of capabilities. As Vaughn said earlier, a product changes, right? There's a life cycle to entities. And when the entities go through a life cycle, they go through different business capabilities or services. And it's not an IT system. Yes, you may have IT to solve your capabilities, but you don't have to. It can be a manual process. I mean, businesses work before you have IT, right? The capabilities were there back then too. But what we did with IT was they automated a lot of those capabilities. We supported them, make them more efficient. We even created new capabilities because we can do that. But it's not an IT system per se. So that's a really good heuristic if you want to find the capabilities. Don't get locked into the IT. Picture it how it worked before. And there's another part here that is probably a bit tougher on the ones that are not being consultants as I am. You can be outsourced. The capability is a brilliant component you can outsource if you do it correctly. Because as I said earlier, they are self-contained, they are cohesive, there are people there, they are independent of the rest of the capabilities. So in theory, you should be able to outsource it. Not saying that you should, you can. So our capability is defined by strategy. Is it really? That's probably why we haven't heard that much about it, because it's basically mostly used in the business as part of their strategy work. And within a capability, there are processes, not business processes because they go across, but there are processes within them. Transactional boundaries, for example, that's along. People live in business capabilities. Nothing lives outside the capabilities, even people. Information is owned by each capability. As I mentioned earlier, the entities, if you want to really do a good split, each capability should own part of that entity. If you get to that level, you're independent. You can get independence. and there can be technology in that. Not necessarily, as I said, but it can be. So, okay, let's do an example. This is taken from one of colleagues' presentation, but I think they're used in the open group paper as well. That's an example of the enterprise. You got corporate management. He's used the management a lot for some reason. I don't like that using that generic word. Let's use the example. You got corporate management, that's a capability. You got market development, that's a capability. Product development, delivery, support and services, and oversight. This is managing the business, manage the internal capabilities that you need to be able to run the business. And these are the customer outlets. This is probably also management of the system. And at the top level, there's a rule of thumb is that there should be about 10 every business. And average business, say. For example, for Telenor is probably more. And for some other business and small business, probably less. But rule of thumb could be 10-ish. And then you break it down to hierarchies, and you say if you dig into market developments, that is composed by a lot of capabilities themselves, right? So you've got contract management, direct marketing management, order contract management. As I said, they use a lot of management there. I don't like that. Be more creative with the names. I actually got an example from which we worked at a customer of mine. I try to get not using, actually being deliberate about using management or generic words. So you have sell services, manage services. You have customer services as in service you provide for the customer. You help customers, you deliver services, you manage the business, and you manage equipment. This is telecom. Somebody can make that. And deliver service, you can break that down. And you can break it down even one level more or even one level more. But it's 3 levels is probably all that you need. Yes. So let's try to summarize a bit. The first points I want to make is that you use, and that's probably where EA is using it the most, so use it for business consulting. When you talk to business about strategies and how you should do your business and what you use business capabilities, that's the way of talking to them. Use it as for analysis. Use it for strategic planning. Which sort of business capabilities are we going to be better than our competitors in? What is our what should be our competitive advantage? What sort of capabilities do we really want to be good at? And for that, you can use heat maps. A lot of EA architecture are used to this. An example of that is here, taken from the same paper. But do you notice those 3 over there? Those domain design people over here. There's something similar, right? So there's a lot of overlap here between domain-driven design and the way this business capabilities and so are done. And here are the heat maps. You say that all these capabilities are strategic to us. This is really important to the business. We need to do it well. These are green. We are not so good here. We need to make some effort to make our capability better here. Either better systems or better people or whatever. And you can heat map it. And you also say that these, they use different terms than domain-driven design, so it's confusing, but core here is basically supporting. What we call supporting. And supporting here is what we call as a generic. But yeah, it's the same three-term divider. So you can outsource the latter one because they are not your competitive advantage. You want to focus on the top ones. So you see, what I think we can use capabilities for is identifying both the services and then also the domains that we work. Okay. Say if this was a telecom again, and if this was a telecom, yes, the domain is telecom, but what are these subdomains? Maybe business capabilities can be a good way to find those. I'm not saying this is the only one. As Vernon mentioned, you have context mapping and you have ubiquitous language and all that. It could also help you, but this also could be a really good tool. And this is where, so this is EA. All of you have EA's people out there, you're probably familiar there. And also here, the data management, where you put information, where you master data management and all that. And what I love about it is that you can use it for technical design. I don't think EA do that a lot. You can use it to plan your monolithic split. If you got that map, You have a map to follow when you're splitting up to your domains. So if you take a component here and a component there, and they all both belong in custom management, then they should belong here, and they should have loose copy to everything else. Have a map. Yes. And the last one, which is a bit contentious, is that you can use these capabilities to define your organization. It's a bit risky, because that's the errors that I showed earlier. Organization is all the way to the right, and organizations tend to change a lot. So you should be careful here, and you should actually, if you do that, you need to be aware that the organization is going to change a lot, and you need to be able to adapt to those changes. So be a little bit careful. There's a lot of things. They probably one quarter they want to focus on that customer segment, and next one the other one, or something like that. And then you need to change your strategies for the business capability. So be careful doing that with the organization. But it can be done. It can be an inspiration at least. Yes. There's also, I have to mention this, I came across this study from a Chinese organization. I believe it was an electric company with 66,000 employees, so not a small one. And they went for this type of split up. And they call, you know what they call them? It's gonna be funny. They call them micro enterprises. Micro everywhere, right? But then again, this is what Amazon is doing. Right? Things to be learned a bit. Yes, that brings me to the last slide. So, as I mentioned, business capabilities can be one way to find your domains, one way to split up your monolith or creating your microservices or services or whatever you call them. But it's not necessarily the only one, but it can be a good way to start. But it takes a lot of effort. I tried. I started a best, as I mentioned, back in 2014. We tried to do a session to at least create level 1. We didn't get past the IT architect. Because we don't know who the business are. We don't know who to talk to. Okay, let's give it up, right? So we started the monolith split with low-hanging fruits, as I mentioned. That project is stuck still. They haven't got any further. They still have plans for doing a next. They started with version 1, for example, and it's still at version 1.2. They started to get finance for the 1.2. They haven't got anywhere. Yeah, and yes. So the other alternatives could be to use context mapping. Match it. You have to match your context mapping. If you have a business capability map that sort of have a rough idea, test it using your context map. Does it match your context map? Either the business capabilities models are wrong, or maybe you have misunderstood the concepts in the context map. Maybe the product doesn't really mean product there. Ask the customer, ask the business again, do you really mean product there, or is it something else? Yeah. It could help you. Yeah, and there's a lot of other stuff. Event storming, highly recommended. Entity life cycles, as I mentioned earlier. Look at the entities. Say if you have a customer, when does that change life cycle? When does it change? And where it changes from one state to another, you probably have a border between two capabilities, or two services, or two domains, or one. You also use the story mapping, which I use a lot, which is a way of discussing the requirements with the business. And not necessarily the user story mapping is going to help to find the domain, but it's going to help you understand the domain enough so you can find the boundaries and the services and domains. And also got the usual suspect, the value chain analysis and business process and all that. So, so the whole point here is that you should focus on the what, not the how. And we do that a lot. I sure has done it a lot. You choose the easy path. And the easy path is what you know. So if you're a developer and you're really good at Java 2E, or Java EE, that's the tool you're probably going to use for your next stuff. Right?